Our next speaker is Dr. Usharani Gogoi. So, Dr. Usharani Gogoi completed her Bachelor of Engineering degree with honors from Guwahati University in Computer Science and Engineering. She held the first-class first position in her Master of Technology degree in Computer Science and Engineering from Tripura University, a central university, in 2014. She received her PhD degree in engineering from Tripura University in September 2020. From August 2020 to January 22, she served as an assistant professor in senior grade 1 in the School of Computer Science and Engineering, Vellore Institute of Technology, VIT University, Amravati, Andhra Pradesh. And since February 22, she has been serving as an assistant professor in the Computer Science and Engineering Department of the Neotia University, TNU. Dr. Gogoi has more than 6 years of research and 4 years of teaching experience. She has published 3 book chapters, 6 conference papers, and 6 journal articles. Some of her research works are published in IEEE Journal of Biomedical and Health Informatics, Physical and Engineering Sciences in Medicine, in Springer, Infrared Physics and Technology elsewhere, Quantitative Infrared Thermography, Taylor and Francis, and Water. Her areas of research and are medical image processing, artificial intelligence, machine learning, deep learning, pattern recognition, computer-aided system design, soft biometric, etc. She has also served as an active reviewer of many well-renowned journals. Some of them are IEEE Access, Physical and Engineering Sciences in Medicine, APES, Springer, Journal of Medical Engineering and Technology, Taylor and Francis, etc. Now over to ma'am. Please, you can start your session.
Thank you. Thank you for the nice introduction of mine. And yeah, I am very much thankful to the organizing team for giving me the invitation to share my knowledge with you all. And best wishes for all the participants to have a great session with me. Okay, so as we all know, our FDP is on recent research trends on AI and ML in interdisciplinary domain. So today I will mainly focus on different applications of AI ML across diverse fields. So this is the outline of my today's presentation, where first I'm going to discuss a little like a brief description about AI and ML. Then I'll just give a I'll try to just give a a brief description about the interdisciplinary research, then what is the importance of interdisciplinary research and how AI/ML helps us to do this interdisciplinary research. Then I will discuss some major applications of AI/ML in various domains. Then I will conclude my slide with a demonstration of my project work. So before starting the session, just I want to show you one thing that here, as we all can see, so here what is written. Hello everyone, I am Guinea. How can I help you? So can you identify this mutual friend for all of us? Yeah, this is our friendly chatbot, always ready to help us in anything, anywhere. Like from booking tickets, e-commerce shopping, healthcare to our daily day-to-day transaction also, our friend is everywhere. But the question is how this Guinea becomes so intelligent? Here comes AIML, the ultimate guide of genie. So with this simple example, let us understand what is artificial intelligence and machine learning. So artificial intelligence refers to the simulation of human intelligence in machines.
I'm sorry to interrupt you, ma'am.
Yes.
Your PPT is not visible, ma'am.
Is it?
Yes.
Just now you see, so just let me go with the artificial intelligence and machine learning. So artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think, learn, and solving problems like human. AI encompasses a wide range of techniques and approaches aimed at creating systems that can perform tasks that typically require human intelligence, such as understanding natural language, recognizing patterns, making decisions, and solving problems. Now the question comes that how machine learning is different from the artificial intelligence. So machine learning is a subset of AI that focuses on the development of algorithms and statistical models that enable computers to learn from and make predictions or decisions based on the given data. So it involves training algorithms to recognize patterns and relationship within data without being explicitly programmed to perform specific tasks. Now the question is why AI machine learning is called without being explicitly programmed. As we all know, whenever someone asks us the definition what is programming, we all know that we have a set of data, and or you can say we have an input, and for that input you or for the problem we have to write some code. After getting the input with the code or the logic, we used to get the output. But the machine learning, where we used to apply this machine learning, we know all of us know that machine learning is applicable for solving the complex problem where the logic cannot be decided. That means we have the input as well as we have the output, but we don't know the pattern, we don't know the logic to write the code. So in that scenario, machine learning will help. With the help of this input and the output, it will just help us to draw some pattern or to write the logic or to get some model that will fit that particular model, and which will predict something which is very close to the output. So that's why it is called without being explicitly programmed. So next come to the slide, what is interdisciplinary domain or research? So it is a collaborative effort that integrates knowledge, methodologies, and approaches from multiple academic disciplines to address complex problems or questions that cannot be adequately tackled within the scope of a single discipline. Researchers from different fields working together to combine their expertise and perspective in order to generate novel insight and develop innovative solutions and advance understanding. So, in simple words, what is interdisciplinary domain? Let me give one example for this. Say you just think about the doctors, how doctors use computers to analyze big set of data about the diseases. That brings together the medicine, like to understand the disease, computer science to work with the data, and sometimes even ethics to think about how to use the data responsibly. So, as evident in this example, interdisciplinary research is all about of not just using a tool or idea from one subject like mathematics or biology or like chemistry, but interdisciplinary domains bring together tools and ideas from different subjects. So, what is the importance of collaboration across diverse fields? So there are some key points that reflects the importance of doing the collaborations. So first one is the comprehensive problem solving. So collaboration allows the experts from different domains to bring their unique perspectives, methodologies, and insights that lead to more comprehensive problem-solving approaches. Then the second advantage is innovation and creativity. So collaboration across diverse domains encourages to share and exchange of ideas and the exploration of new approaches leading to novel solutions and breakthrough discoveries. Now, third one is the addressing grand challenges. So what does it mean? By working together, the interdisciplinary team can bridge the gap between theory and the practice, ensuring that the research findings have practical relevance and social impact. Then translational impact. Exposure to diverse perspectives and interdisciplinary approaches helps to cultivate critical thinking skills, adaptability, and interdisciplinary collaborative skills. So overall, collaboration across diverse domains fosters innovation, and it enhances problem solving capacity, promotes a more comprehensive understanding of your complex issues, and it accelerated the progress towards addressing grand challenges and improving the well-being of the society. So now the question is, what is the relationship of AIML in the interdisciplinary research? That means how AIML helps us to do the interdisciplinary research. So AIML provides us some benefits for which nowadays AIML is everywhere. So the major advantage of AIML are discussed here. First is the data analysis and interpretation. So AIML algorithms are very good at handling your large and heterogeneous data sets, which are collected from the diverse sources. The data can be text, images, audio, or it can be sensor data also. Researchers across various domains can use AI and ML techniques to analyze these complex data sets, identify the patterns, trends, and correlations, and extract meaningful insights, pattern recognition, and the prediction. The second benefit provided by the AIML. So this AIML algorithms are very much excel at recognizing patterns and the relationships within data. Interdisciplinary researchers can use these ML models to predict the outcomes and the focus trends. Third one is the automated feature extraction. Extraction of, like you can say, the relevant feature is very much crucial to find a solution of a complex problem. And ML algorithm has the potential to automatically extract these relevant features or characteristics from the raw data, reducing the need for manual feature engineering. The last but not the least, least but not the last one is the enhanced decision support. Interdisciplinary researchers can use AI-powered decision support systems to optimize resource allocation, design interventions, or developing policies. So here I'm going to discuss some research trends of AIML in interdisciplinary domain. Here I'm just listing out very few domains. AIML can be used in multiple domains, but I have just going to portray only few domains. Like first one is the healthcare and medicine, then your education, then in autonomous vehicles, then business, travel industry, social media, fraud detection, agriculture, and environmental science and sustainability. So I used to do research in you're mostly on the healthcare and medicine, and some other areas where AIML is most widely used are like agriculture and also in environmental sciences and sustainability. So here I'm going to discuss some specific problem statement where AIML is used. So AIML in healthcare domain. So first one is the medical imaging analysis. So AI and ML techniques are transforming medical imaging analysis by enabling automated interpretation of images such as X-rays, MRI, CT scan, and histopathology slide. So to analyze this concept, here I'm taking an image of the journal paper published entitled Brain Tumor Segmentation and Survival Prediction using Multimodal MRI Scans. So as authors have suggested here, how the medical image, how we can use the AIML in medical image analysis. Here, as you can see, some set of brain MRI image has been taken, from where the authors have used three different convolution network to segment the tumor region. Then from the segmented region, they have extracted features. The features they have extracted includes first order statistics, like your mean, median, mode, all those things. Then the safe features like elongation, diameter, then your major axis, minor axis length. Then they have also extracted the texture features, the features like gray level co-occurrence matrix and gray level runlet matrix. They have extracted 22 gray level co-occurrence matrix and 16 runlet matrix from different region of the tumor. Then once they have extracted the features, they are not going to use the all features for their prediction problem. So they did the feature selection by using the importance ranking, like some feature selection techniques, and then they have used another method like k-based cross validation one to find out the k-based feature. Then these features are used to predict the survival of the person or the patient by using a random forest algorithm. The second one is the clinical decision support system. So, AI-based clinical decision support systems assist healthcare providers in diagnosis, treatment planning, and patient management. So, as we all know, like when a patient used to visit the doctor, so sometimes it happens that the patients are having some symptoms which are common for different diseases. And that scenario, the doctors are very like without any test, the doctor cannot conclude that what disease is happening to the patient body. So at that moment, the AI-based decision support system can help the doctor to to provide a second opinion and to take the decision also. So how the AML will how AML can be used here also. So you can see here as in the shown in the figure. So the data collected from the laboratory test, the basic information of the patient like his food habits and his regular his age, weight, all these things, and then the features the informations from the symptoms and some monitoring data. All these data, from this data, some kind of features will be extracted, and then that features, the extracted features will be fed to some machine learning algorithm, and that algorithm, by analyzing the patterns in the data, given data, they will come to a decision, and that decision can be used by the doctor as a second opinion to make a proper decision so that he can prescribe some medicine to the patient. So this is a clinical decision support system application of AIML. Next is the remote patient monitoring and telemedicine. So as we all know, in India, the doctor patient ratio is very low. It's almost 1:1,000. That means for every 1,000 patients, there is only one doctor, which is very difficult to manage. So in that scenario, in remote areas, it due to the absence of proper doctors, so this remote patient monitoring and telemedicine plays a very you can say vital role. So how we can apply AIML in this particular field also. So here we all know there are some sensor devices. So based on the sensor devices, the patient data are collected, and those will be collected through some apps or some like a smartphone. Then they will be stored in the cloud. Okay, now from the cloud, the doctor has that credential to access the data. Now doctor from anywhere in this world can access this data, and he can provide his opinion to the patient. So this in this way, the AIML can be used in remote patient monitoring also. Next, drug discovery and development. Nowadays, you can see AML is very widely used in drug discovery and development. So three specific projects that you can focus on, like one is like antibiotic discovery, then another is biomarker discovery, and detect the drug efficiency. So in antibiotic discovery, the main problem statement is like we all know the antibiotic resistance, the human health is antibiotic resistance. So every day there is a need of finding some new antibiotic. That means the proper composition of the combination or the ratio of the molecules to form some new antibiotic to resist some disease. So that discovery, because it's not possible to find out manually the what concentration of the molecule should be combined to kill a bacteria. So better we can apply the machine learning algorithms by doing some trial and error method, or by applying some kind of your optimization techniques. We can find out the you can say the base concentration of the molecules to form a new antibiotic. Then you can also use this AIML in biomarker discovery. So analyze large scale of omic data such as genomics, proteomics, and metabolomics to identify potential biomarker for disease diagnosis, prognosis, and treatment response. Then detect the drug efficacy. Say once doctor prescribes a medicine, now to find out whether the medicine is has the efficiency to kill the bacteria or not, or to cure the disease or not. So that also can be detected by the AIML by looking at the you can say the recovery stage of the patient upon application of the disease. The drug. Next is the predictive analytics and risk stratification. So AIML models are also used for predictive analytics and risk stratification to identify the person at high risk of developing certain diseases or complication. At the last part of my slide, I'm going to show one of my projects where I have performed I have applied this AIML in some kind of predictive analysis. So next, application of AIML in environmental science and sustainability. So these are some key areas where you people can work. So as you can see, remote sensing and Earth observation. AI and ML techniques are applied to analyze remote sensing data like satellite imagery or aerial photographs to detect the land coverage, or to detect the vegetation monitoring, like is there any deforestation or anything happening over the earth. Then you can find out the prediction and detection of natural disasters by looking at the satellite image. Uh, by applying the machine learning algorithms, one can easily find out whether it is there any wildfires happening or any cyclone is going on, like that. Then your urban planning, to create, like to construct some new buildings, to find out the proper area for that. Then urban waste management also, we can apply AIML. Then tracking carbon emissions in different industrial areas, like you can say the where the some chemicals are like exhaled by the industries. Then infrastructure monitoring in railways and airport mapping. These are some key areas where AIML can be used, because nowadays the research in environmental science and sustainability is very like you can say like very popular. Okay, so next is your climate modeling and prediction. So AI and ML algorithms like neural network and ensemble learning are applied to analyze the climate data, identify patterns, and make accurate predictions, and thus improve climate models for predicting future climate scenarios, extreme weather events, and climate change impacts. Then also AIML can be used in natural disaster detection and response. That means you here we're not going to design a model to detect the natural disaster, as well as we'll take some preventive measures also, like creation of some alarming system based on that. Once the system detects there is a wildfire or any kind of cyclone is there, so it will create some, give some alarm. So this type of system can also be designed by using AI and ML. Next, your environmental pollution monitoring. AI and ML models are used to monitor environmental pollution levels and assess the impact of pollutants on air quality, water quality, and soil health. AI and ML also enables to identify pollution sources, predict pollutants concentrations, and inform pollution control strategies. So by observing that what are the concentration of different molecules in the pollution, so one can also find out the source of the pollution, and we can take some preventive measures also accordingly. So next application of AIML in agriculture domain is like crop monitoring and management. So AI and ML techniques can be used for crop monitoring and management, including the yield production, then its production, like you can say yield production prediction, then disease detection and pest identification. Then smart farming and autonomous system also we can use AIML. AI powered smart farming systems automate agricultural tasks such as planning, irrigation, and harvesting to increase efficiency and reduce labor cost. Then we can apply AIML in soil health monitoring and management. AI and ML methods analyze soil data to assess soil health, fertility, and nutrient content, guiding soil management practices and improving crop productivity. So, after this vast applications of AIML, now I want to focus on one of my own research work where instead of directly applying machine learning, my objective was not to apply machine learning only. My objective was to find out how the accuracy of the machine learning algorithm varies by depending on the number of features. So that's why the title of my research was Importance of Feature Selection in Machine Learning Based Obesity Prediction. So here, before going to discuss about how we can apply machine learning in obesity prediction, let me go with what is obesity. So it's an epidemic disease, as being overweight or obese increases one risk of having life-threatening illness such as diabetic, heart disease, cancer, hypertension, all those things. So early identification of causing factors of obesity will just allow us to prevent these deadly diseases. So while going through different literature, I come to I found that lots of researchers have already developed or utilized the machine learning algorithms in obesity prediction. But I found that although they have reported very huge accuracy or a very good accuracy, but the number of features they have used is very high, and some of the features are also not important for, like you can say, not statistically significant for obesity prediction. So what was my problem statement? Although some works reported very high accuracy or other performance measures, it has been seen that the number of features they considered is very high, and no such work is there that analyze the importance of identifying the significant features in ML techniques for obesity prediction. For this particular problem, you can see here is the flowchart of my research, where after taking the data, so I'll just give a description from where I have taken the data. So I have performed handling the outliers and then level encoding. Then I have used 7 different classifiers. The one is the K nearest neighborhood, logistic regression, then decision tree, random forest, extreme gradient boost, SB support vector machine with both linear and radial basis kernel, then gradient boosting. Then I have used these 7 algorithms or machine learning algorithms to evaluate the performance of my proposed system. Then to find out how feature selection is important for getting a good performance in machine learning algorithms, I have used 4 different feature selection techniques. One is the univariate analysis, then feature importance, then mutual information, then correlation. These are the 4 different features. Next, so just go with a little brief description about the experimental dataset. So in this study, an obesity dataset of 2,111 samples aged between 14 and 61 years has been considered, which is available in Kaggle. In this dataset, each sample is represented by using 17 attributes. Out of the 17 attributes, 16 are independent features, parameters, and 1 is dependent. So in the whole data set, there are total 7 categories of data. So those are insufficient weight, normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, and obesity type 3. So these are the 7. So this is a 7 class classification problem. So as you can see here, in the given data set, there are total 16 attributes excluding the level. So the attributes are gender, age, height, weight, family history of the having any obesity, then FAVC, which is the frequent consumption of high caloric food, then FCVC, which is frequency of consumption of vegetables. Then NCP, the number of main meals the person used to take. Then CAEC, consumption of food and meals. Then smoke, whether the person is smoking or not. Then CH2O, consumption of daily water. Then FCC, which is the calorie consumption monitoring, everyday calorie consumption monitoring, whether he used to do that or not. Then FAF, physical activity frequency. Then TUE, time using technology device. Then your CALC, consumption of alcohol. Then AmTrans, that means the transportation they have used or not. So what type of transportation the person used to use. So these are some features. So after going through doing the code, I have come to know that there is no missing value in this data set. Okay, but I have found that the data set is comprising of some, as you can see here, some are categorical value and some are numerical value. But before going to apply, because as we all know, all the machine learning algorithms are not capable of dealing with the categorical data. Like there are some very few, like you can say naive-Bayes classifier are there that can decision tree also that can deal with your categorical data. But here I'm going to apply different algorithms. So first task is to convert them into numerical data. So as you can see here, family, gender, FVC, then your CAC, then smoke, SCC, CALC, and MTrans. These are some categorical data. So first task was to find out, so three different tasks has been performed. The first task was to find out whether any missing value is there, which is not present in the given data set. Then I have found that some of the features or the parameters are skewed. That means there are some outliers in the data set. So first task was to remove the outliers, otherwise it will just reduce the, or it will just you can say decrease the efficiency of my problem, or sorry, the model. So next task was to handling the outliers. So I just use the lower outlier level I have used as a 0.2 and the upper one is 0.98. Like inside this two range I have kept all the data, and beyond this two range I just discard all the data. Then the second task as a pre-processing, I have performed the conversion of categorical data to numerical data. Now, after doing this, data preparation, next task was to do the feature selection. So as I have already mentioned, I have performed four types of feature selection technique. The first one is the univariate feature selection. So the univariate analysis examines the strength of the relationship between each feature and the target variable. Okay, so it is called univariate because it will ignore the other features while analyzing the you can say the bonding between the feature as well as the target variable. The target variable is the independent variable, the dependent variable one, the level one. So after doing that, after doing the code for that, I come to know that the features has been sorted based on their relationship with the target variable. As you can see in this particular table, weight has the highest relationship or the highest strong relationship with this target variable, your obesity level. Similarly, age has the second highest like that, and the height, the feature height has the lowest relationship with the your level. So this univariate feature selection will help us to rank the features based on their association with the target variable. So next is the correlation based method. So in the correlation based method, the correlation will describe the relationship between the features. So we can perform the correlation in two ways. Okay, the correlation is like we can find out the correlation between, because as we know the dimension is a cause for the machine learning problems. The more we reduce the dimension, that means not more means it's not like that we are going to reduce the dimension or we are just going to take the features only 2 or 3. It's not like that. We have to take that much of feature so that it can cover the variance of the feature by 97% or 98%. Okay, so we have to take that many of features. So in correlation based method, what we used to do, in first approach, either we can find out the correlation between the first any two feature. If both of them are highly correlated, I can discard any of them. Okay, or we can find out the correlation of the any independent feature with the dependent feature. If we find that the correlation between the independent and dependent feature is very high, then we'll keep that particular feature. And if it is low, like low, it will be decided by some threshold, then we'll just discard that. So here correlation will describe the relationship between the features and the target variable. That particular concept I have used in my algorithm work. High correlation features are more linearly dependent and hence have the same effect on the target variable. So here I'm just measuring the correlation between the features and the target variable. So whether positive or negative, our objective is to drop one of the two features when we can see that they are very highly correlated. So based on this correlation-based method, we found that there is no correlation among any two features of the dataset, but two features are there, which is called height and types of transportation used. So these two features have the correlation of 0.64, but my threshold was 0.5. So that's why I'm going to consider any one of them only for the classification purpose. So I have used any one of them, like when I have used height for classification, I have discarded this mtrans. When I have used the mtrans, I have discarded this height. And I have just find out that with which particular feature the accuracy was higher. And I am going to keep only that feature. Next is the feature important based method. It assigns a score to each feature based on the usefulness and relevancy of the feature to the output variable. The higher score indicates relative importance of the feature in making a prediction. So there are several methods like linear regression based, logistic regression based, or extract trees classifier. For our work, I have used extract tree classifiers method for obtaining the score against each feature. And you can see in this figure, this particular method has found that what is the feature importance of every feature. And we found that weight has the highest feature importance compared to the smoke. So like this also we can rank some, you can say rank all the features. Okay, there is a mistake in my slide. So here this should be mutual information based method. Okay, so there is a mistake. So mutual information is used to evaluate the arbitrary dependency between random variables. Mutual information is a measure between two features x and y that quantifies the amount of information obtained about one feature through the other feature. That means if x and y refers to the knowledge of feature, if x and y are two features, then the mutual information between two features x and y refers to the knowledge of feature y supplied by the feature x, or the knowledge of feature x supplied by the feature y. That means how one feature can represent the other feature. So that is called mutual information. So here, when we found out the mutual information value of each feature, we found that every feature is mutual, like any two feature has a good mutual information, like weight has a mutual information of 1.303 and SCC has also a mutual information of 0.002. That means we can say that none of the features are there in the data set that we can remove because all are having some kind of mutual information with the target variable. So after extracting or after doing the feature selection by all of these four methods, the next task is to perform the classification with different classifiers. And here I have just shown the classification accuracy of different classifiers. So first is the classification without performing any feature selection and with the feature selection with the method univariate analysis. So we found that here in this figure, you can see the first figure represents the accuracy of the models and the second figure represents the area under the ROC curve. So as you can see, the features, as I have shown you earlier, the features are ranked based on by using the univariate features. So based on the ranking, I have considered top 5 features and top 10 features. So I have found the accuracy of the system where I have used these top 5 features, and I found that when compared the result of top 5 features of univariate analysis, top 10 features of your univariate analysis, and accuracy of all the features without doing any feature selection, I found that extreme gradient boosting has given me the highest accuracy with all the features. That means, so here the values are given. The highest accuracy of 96.23% and AUC value of 98.74% was obtained with the gradient boost model. You can see here, this is the gradient boost model with all the features. However, the highest classification accuracy obtained with the set of 5 high-rank features and with the set of 10 high-rank features are 87.40 and 89.15% only. So in this way, we can conclude that the way in which the univariate analysis used to perform the feature selection is not fruitful for obesity prediction. In obesity prediction, univariate analysis based feature selection is not effective. So we can go for some other feature selection method. The next one is the correlation based feature selection method. Here you can see if amtrans is considered over height, then we can obtain the highest classification accuracy of 91.38% and the AUC of 93.99%. Okay, but in contrary, if height is considered over amtrans with all other features, because height and amtrans are having the correlation of 0.64. So that's why we're going to consider only one while we're doing the classification. So while we're taking amtrans but not the height, then we got an accuracy of 91.38%. But when we use the height instead of mtrans, we get an accuracy of 96.29%, which is much more better than your mtrans. So we can conclude that although both mtrans and your height is correlated, but height is more effective or more efficient in predicting the obesity. The same thing is reported here also. As you can see here, the gradient boosting has given higher accuracy in excluding mtrans. That means inclusion of height but exclusion of mtrans. Next, classification with mutual information based feature selection. As I have just shown you in this particular this one, here all the features have some kind of mutual information with the target variable. So we are not going to discard any of them. If we found that the mutual information is 0, like as written here, the mutual information of feature X and Y is 0. If they are independent, that means they don't have any kind of relationship. But here, as you can see, they have some relationship. So we can't discard them. So if we can't discard them, then that means what? We can't, that means the mutual information based features are also, the feature selection method is also not applicable for this data set for obesity prediction. Next is your classification with feature importance based feature selection. As I have already shown you the feature importance here in this particular figure, so weight has the highest feature importance compared to smoke. So we can rank them according to their importance. So like the univariate analysis, here also I have clustered the features, or I have separated the features. First I am taking 5 top ranked features, then I am taking remaining 10 top ranked features, then I have taken 15 top ranked features, like that. And once then I try to evaluate the efficiency or the classification accuracy of each set of features, which are ranked based on the feature importance. So here also you can see among all the ML algorithms, the highest classification accuracy of 96.87% and AUC of 98.83% are reported by the gradient boosting algorithm with a set of 5 top ranked features selected by the feature importance algorithm. So when comparing with the classification accuracy without feature selection, we can conclude that instead of considering all the 16 features, it is sufficient. That means what? As you can see in this particular figure, the gradient boosting, the red color represents the classification accuracy of all the features, and the yellow color represents the classification accuracy of the top 10 ranked features, and the pink color represents the classification accuracy of 5 top ranked features. So here you can see, although the classification accuracy of all the features are very close to classification accuracy of the system using only 5 top ranked features, that means what? Instead of using all the features, means all the 16 features, we can find the same or maybe better accuracy by using only 5 features by using the same machine learning algorithm. That means what? We can say that the feature selection algorithm has a huge impact on the machine learning algorithm. So it's not like to find out the only machine learning algorithm, but it's better along with the machine learning algorithm, we have to find out the set of base features that will increase the efficiency or the performance of a machine learning algorithm. So here I have performed one comparative study. Here, as you can see, in almost all the work, they have used huge number of features of 167, then 5 features. But here in this paper in 2018, the 5 features have reported accuracy of 89.68% only. And another 1 feature is used by this paper in the year 2020, and they have also reported very a poor accuracy of 52% for imbalanced data and 92% for balanced data. And another work which is reported in the year 2021 by F. Farousi, he has reported 97.07 and we have reported 96.87%. But the thing is that they have used 1100 samples and we have used total, after removing of the outlier, we have used total 1856 samples, and they have used 28 features. We have used only 5 features and they have reported accuracy of 97.07 and our accuracy is almost 97. So we can say that by reducing the feature size also, we can able to get the same accuracy with the same machine learning algorithm. So that was the main target of my work, to find out how the feature selection algorithm impact on the machine learning performance. So you can also use this concept for other domain. So these are some observations. The highest obesity prediction was reported by F. Rossi by using 28 features. On the contrast, our approach of classification also reported almost 97% accuracy with only 5 important features selected based on the feature importance based feature selection method. So this classification results signify the importance of feature selection techniques for comparing the performance of different machine learning algorithms in obesity prediction. So with this slide, I'll just conclude my presentation.
Thank you, ma'am, for this knowledgeable session and for sharing your research work with us.
Okay, thank you.
It was a wonderful time having you with us. Thank you, ma'am.